By the end of this lesson, you should be able to analyze surveys and samples and the results of those things. So evaluating survey results, evaluating and validating samples, and then also kind of does your conclusion match up with the data you got. So if after a survey has been summarized and someone reports the findings and they make some conclusions, it's important to be able to look at those conclusions and see if it actually matches the report. Okay, you need to make sure, hey, was this sample truly random? Was the sample large enough to be accurate? If I wanted to find out about all the high schools in your county and I only asked 5 students, that's not large enough. So that we want it to be an accurate representation of our population, and that the source of the data is reliable. All right, does it match up with with what our population is? It's also good to check graphs accompanying surveys to make sure that they're not misleading results. Okay, so this is about making sure that what is concluded actually can be concluded. So what we're going to do is, given the following information of a survey report, we're going to evaluate the validity of the information and the conclusion. Okay, so school uniforms. A survey of the Survey USA polled 500 randomly selected adults in Cincinnati, Ohio by phone. So they called 500 random people. And the question is, should public school students wear uniforms? And the results were that 58% said that you should, 36% said that you should not, and 6% said they weren't sure. So my conclusion, or a conclusion would be, adults in Cincinnati believe students should wear uniforms in school. So first we want to know, if we want to decide if it's valid. So let's look at it. So first of all, it's random. Okay, it's a random sample, which is good because I just randomly called 500 people. I didn't ask for results back. It's not like I mailed something out and asked for people just to send results back. All right, I talked to 500 people. And 500, that's a big enough sample. That's a large number, so it's a big enough sample. And then let's look at our conclusion. So our conclusion says adults in Cincinnati believe students should wear uniforms. And if we look, it was a majority. 58% do say that students should wear a uniform, which is bigger. The people who said should not was only 36%. So I say the conclusion matches the data. Conclusion follows the data given. So because of all these things, I would say this is valid. Okay, I would say this is a valid conclusion. I would consider it valid. It was random. There was a big sample, and then my conclusion matched the data. Okay, it said 58% said they should, and only 36% said they should not. State Representative Beck commissioned a poll of 400 randomly selected adults visiting a mall in her district. So let's say it was like Patrick Henry Mall. Do you approve of the job? The question they asked was, do you approve of the job State Representative Beck is doing? 44% said they did, 32% said they didn't, and the undecided was 24%. So we want to know, and the conclusion is Senator Beck will win re-election. So based on this information, is this enough to say, hey, Senator Beck's going to win re-election? I think for a couple reasons this would not. First of all, not all people in the mall may be from her district. So I go shopping in Patrick Henry Mall, but my state representative, I go shopping at that mall. That mall's in a different district than I live in. Okay, so first of all, not all people in the mall may be in her district. So that might be that undecided or unsure. And people may like her, like, oh yeah, she's doing a great job, but they don't live in her district, so they can't vote for her. The other reason I didn't like this data is because it's really close, so the data's close. All right, so the yeses and nos are close. Maybe we should write that. Yes, nos are close. Okay, 44 and 32, I mean, that's far apart, but not that far apart. And there's a lot of undecided. And there is a lot of undecided voters. So let's say when I went and did my survey, I was like, oh, do you live in this district? And let's say they all did. I still would say, hey, these results aren't too valid because I don't know if she's going to win re-election. What if all of those undecided people go with the no? All right, so now we have a majority of people saying no for her. So I would say this may not be valid. All right, so part of this lesson is being able to look at data, look at a conclusion and say, hey, was my sample random? Does it actually match my population? So this one doesn't even match what my population is. Because if I poll 400 randomly selected adults, they might not live in my district. All right. So even though it's random, it doesn't really represent my population. And also, if I look at my results, it's a little misleading to say, hey, she's going to win because, oh, it's 44%, which is bigger than 32. Well, there's still a lot of people who are undecided. Sometimes you can make predictions based about a population based on your sample, based on the smaller sample population, depending on the method you use to collect the sample. So if your method is good, then you can say, hey, I can use this data to then make up a prediction about my population. So we're going to go back to, if you remember in the previous lesson, we talked about biased versus unbiased, and we had simple random, stratified random, and systematic random as unbiased samples. So if my sample is one of those three, then I can say, hey, I can use this data now to make a conclusion about my population. Or convenience and voluntary response samples where, hey, this is biased, it's not going to be a good representation of my population, so I can't use my statistic to then make a conclusion about my parameter. All right, so let's look at example 1. To determine the consistency of a printer, 100 printed sheets are randomly checked. So I'm just going to randomly check 100 sheets. And 4 of those 100 were defective. What type of sampling method is this? About how many defective sheets would be expected if 2,400 sheets were printed? So it's just, I just randomly pick, and I'm not putting it into categories, and I'm not saying, hey, every 10th one or every 5th one or every 4th one. So this is a simple random sample. All right, so because it's a random, simple, random sample, then it's unbiased, so I can use this to make a conclusion. So it said 4 out of the 100. All right, so there was 4 defective for every 100 sheets. How many defective would be if I had 2,400 sheets? So I'm going to use proportion to do this. So 4 out of 100 were defective. So how many out of 2,400 can I then expect to also be defective? So we can use a proportion for this. So defective over total. So 4 out of the sample of 100. How many over the population? All right, so I'm going to cross multiply. If you guys remember how to cross multiply. So I'm going to do 100 times x equals 4 times 2,400. So 100x equals 9,600 when I multiply those, and then I divide by 100. cross multiply and divide. So when I divide, I get 96. So since 4 out of the sampled 100 sheets were defected, if the population is 2,400, then I can say, hey, I probably have 96 of those sheets will probably be defective, which sounds like a lot to me. All right. A movie theater manager hands out surveys to 100 customers before a movie begins. At the end of the movie, 40 customers return their survey. Of these 40 surveys, 32 of them said they had a bad experience. What type of sampling is this? Is it an accurate sampling method? If so, how many customers had a bad experience? So I give 100 people a survey, they watch their movie, and then 40 give it back. A huge majority of those, 32, say it wasn't a good experience. This is an example of, remember we talked about voluntary response sample. So a sample which involves only those who want to respond. If you had a bad experience, you are more likely to respond to a survey about if you had a bad experience. All right, so what type of sampling is this? This is a voluntary response sample. Okay. Is this accurate? No, this is not accurate. Not accurate. So anything that's biased is not accurate. So we don't go to say how many had a bad experience. The only numbers, we can't use that to make something about the population as a whole. So we got about half, we got less than half. And of those 32 had a bad experience, we can't say, oh, well, 64 then had a bad experience because 32 of the sample did. We only know that 32 people had a bad experience. We can't make assumptions about the others because they just didn't turn in their paper. So whenever you do this voluntary response sample or comment card, stuff like that, people are more likely to complain than say, oh, I had an okay experience. So this is not an accurate representation to say how many total people had a bad experience. We know 32 did, but we don't know if more did. And so we can't do like the proportion like we did before. We wouldn't do like 32 over 40 equals X over 100. Okay? Because this is a biased sample. All right, so let's look at this graph. A television station interviewed 400 random chosen voters. They said, what issue matters most to you in choosing a candidate to vote for? So the conclusion is most voters do not care about the environment. So if we look at the environment, it's the darkest one, which is 4%. And they say, well, I guess most people don't care about the environment. But you got to go back and look at the question. They said, what matters most to you? All right. So it matters about. So just because, let's say, war matters most to me doesn't mean I don't care about the environment. Maybe that's my number 2 issue. Like after war, then the environment's my next issue. Or after social issues. So let's say for everybody, the environment is your second. There's still a lot of people who care about the environment. So this is not a good conclusion. All right, not a good conclusion because it asks what mattered most. They could still care. Mattered most. They could still care about the environment. Okay? So you're going to finish up. You're going to do 4, 5, 6, 7, and then 6, 4, and then 5, 6. All right? And what you're doing, again, is you're looking at information and deciding, hey, if this is, does this support my conclusion? Does this data support my conclusion? If it does, or if it is valid, what kind of assumptions can I then make about my population? Okay?